Hi everyone. For this question, we're going to discuss a piecewise function. For question A, show that limit x approaches 0 for the function exists. Then determine whether function is continuous at x equals to 0. So first of all, when we get piecewise function, we draw it in interval. Less than 0, function is 4 over square root 4 minus x. Exactly equals to 0, it is square root 2. Then more than 0 means this side x over square root 1 plus x minus 1. For the first question, show that limit x approaches 0 is exists. So to get limit exists, we need to identify x approaches 0 from the left, and we need to see limit approaches 0 from the right. Is it they are same? If both answers are same, means limit for approaches 0 of the function is exists. So to simplify this, when I substitute 0 inside, this is square root 4, this is 4 over 2, answer is 2. Meanwhile, for this side, when I substitute 0, it is 0 over 0 in the case of IDF. So in the case of IDF, we need to simplify. For the third function, we simplify by its conjugate. Multiply with its conjugate, 1 plus x plus 1 over square root 1 plus x plus 1. Simplify its conjugate, a minus b, a plus b, it will give us a squared. So square root and square cancel. Then minus b squared. At numerator, we rewrite in product form. We don't need to expand, we simplify the conjugate part. And we can see 1 minus 1, it gives us 0. Remaining is x. So x divided by x also can be cancelled. Simplify. So our IDF form is already simplified where x is cancelled. Now we evaluate the limit again. Substitute 0 inside. It gives us 1 plus 0 square root plus 1. So this is equals to 2. And we can also limit left hand side, limit right hand side. Limit x approaches 0 from the left equals to the limit x approaches 0 from the right. So this limit is exists. When this limit is exists, you have to write it. What's your answer? So the limit of the function, they are equal. So it is equal to 2 where this limit is exists. Don't answer me as it exists only. So you have to write it if your limit is exists, tell us what's your value. So that will be your part A. Then we continue for part B. Determine whether it is continuous at x equals to 0. When we want to determine the continuity at x equals to 0, we need to identify our continuity condition. So first condition, f0 at the dot. When x equals to 0, we can see our function is square root 2. Alright, so first condition is defined, is fulfilled. Second condition, we see limit x approaches 0 from the function. As we calculate in the part A, it gives us value 2. So this limit also exists. So second condition fulfilled. For the third condition, we need to make sure the coordinate and the limits, they are same. So very obvious, point doesn't same with limit when x approaches 0 from the function. When third condition doesn't fulfill, we can conclude that. So function, answer the question, function is not continuous at x equals to 0. Alright, so that's all for this question.